This is Mr. Halsey of A Squared, it's officially understood science, and today we're going to be taking a look at distances in the universe. So before we begin, let's discuss what cosmology is. It's the branch of astronomy that deals with the origin, large-scale properties, and the evolution of the observable universe. So looking out at the stars and the universe and how it's taken shape and form over the billions of years of its existence. One of the biggest units of measurement we have here is the astronomical unit. Now, here on Earth, we use things like feet and meters, kilometers, miles. But to be honest, those numbers don't work when we're talking about space because it's just so big. And so we created what's known as an astronomical unit. So this is a unit of distance equal to the average spacing between the Earth and the Sun, about 150 million kilometers or 93 million miles. And this is the unit that we use here in the solar system is the AU or astronomical unit. Now it takes light about 8 minutes to cover this distance, so 1 AU is 8 minutes in light years. So light travels, it takes 8 minutes for light to travel to the sun, from the sun to the earth. And so we created this because 93 million miles is just way too much. When we start recording like distance to Jupiter or even Neptune. So we created a brand new unit of measurement. So the use of an astronomical unit was great when we were just measuring distances in objects in our solar system. It was relative, it made sense. But when we started measuring distances to other stars in our galaxy, astronomical units, they just became insanely large. And so we created a new system of measurement for looking at further away things called the light year. So a light year is the distance that light travels in 1 year in a vacuum. This is equal to 9.5 trillion kilometers or 6 trillion miles. Light travels about 300,000 kilometers per second or 186,000 miles per second. So this is extremely fast. So you can just imagine, 9.5 trillion kilometers. That's an insanely massive expanse. But we had to create this when we started looking at other stars and the distance from the sun to other stars. But even then, this wasn't enough. In fact, when we started looking at other galaxies, like our distance to other galaxies, we had to create another unit of measurement known as the parsec. This is a unit of distance equal to about 3.26 light years or 206,265 astronomical units. So you can see that's a pretty big number of astronomical units while we move the light years, and that makes a lot of sense. So parsecs are used to measure distances between galaxies. And there's more of them, but they fall under these three. So gigaparsecs and things like that. So one of the big jokes, if you notice down in the corner, I got a picture of Han Solo. Was Han Solo said he made the Kessel Run in less than 12 parsecs, like he was saying in a unit of time. But parsecs is actually a unit of distance in science. So sorry, Han Solo. It's a measure of distance, not time. Of course, they tried to retcon that in the newest Han Solo movie that they came out with. But, we're not talking about that. Anyway. Now, one more term we need to know for measuring distance in space is parallax. Now, this is something that we've spoken about previously. So this is the apparent shift of an object in position when viewed from different locations, and it's used to measure distance. So for example, if we're looking at a star, and in the night sky. Okay, so the star doesn't move, but we are moving. So as we go around, when we're in this month, January, the star appears right here in the night sky. But as we move around the sun, this star has moved over here. And so this gives us a distance to measure. And so that allows us to figure out what the distance is of objects far off and how many light years it takes. And so that's it for this little mini tutorial. We'll pick up next time with timeline of the universe. But until then, make sure to like, share, and subscribe, and hit that bell notification to know when we post new tutorials. This has been Mr. Holsey with H Squared's Officially Understood Science. We'll see you next time.